Hello everyone. In this video we shall discuss about isomers with more than one chiral center. Chiral center is also called as chirality center or chiral carbon or stereo center, stereogenic center or asymmetric carbon. All are same. Last video we have understood the what is chiral center and what are the configurations, means RS configurations of the compounds having one chiral center. 3-chlorobutanol structure. Here you can see that there are two carbon atoms are chiral centers. This is chiral because this carbon is attached to CH3, Cl and hydrogen. There is one hydrogen. So all the four atoms, this is carbon, all the four atoms which are attached to this carbon are different, hence this is chiral carbon. This is also chiral carbon because all the atoms, all the four groups which are attached to the carbons are different. Hence in this molecule we can find the two chiral carbons. When we have the two chiral carbons, we can describe the relative configuration of that molecule of that isomer by giving the prefix. Those prefixes are called as Threo and Erythro. Then what are Threo and Erythro? Let's discuss about Threo and Erythro. When the two identical groups are attached to the two chiral carbons on the vertical line, then we can give the prefix as Threo and Erythro. Here in this example you can see these are two hydrogens, these two are chiral carbons. These are two identical groups attached to these two carbons on the vertical line. The chiral carbons should have two identical groups on the vertical line. Here hydrogens are vertical or on the vertical line or identical. Here when the two identical groups are on the same side, when these two groups are on the same side, and we have to use the prefix Erythro. But see the example, third example, here these are two identical groups are opposite, hence these are Threo. Here hydrogen, here also hydrogens are on the same side, hence we can use Erythro. This hydrogen means the same groups are on the opposite side, hence we have to use a Threo. This is the second example. Here BR same on the vertical side, which are on the same side, hence here also BR and BR are on the same side, hence you have to give the prefix as Erythro. But here same groups are on the opposite side, here also same groups on the opposite side, so that we have to use the Threo as prefix. To this example also we can give the Threo and Erythro. OH same side, here also OH same side, hence this is Erythro. Hydrogen and OH are opposite side, here also OH opposite side, hence this is Threo. Like this we have to give the prefix for the compounds having two chiral carbons. The optical isomers can be divided into two main classes are called enantiomers and diastereomers. Then what are enantiomers and diastereomers? When the isomers are non-superimposable mirror images. When the isomer is can have the non-superimposable mirror images are called as enantiomers, and the isomers which are non-mirror images are called as diastereomers. See here, this is enantiomer. Enantiomers are non-superimposable mirror images, and diastereomers are non-mirror images. Let's understand this by taking an example. See here, these are the two isomers. These 1 and 2 are isomers. Here you can place the mirror here. These two are mirror images. This is the mirror image of this, but these are non-superimposable mirror image, because you can imagine that you can place this compound on this CH3, place on the CH3, this CH3 place on CH3, but OH will be on the hydrogen, Cl will be on the hydrogen, H is on the OH, H is on Cl, so that these two compounds are non-identical, means non-superimposable. These are mirror images, but these are non-superimposable. Hence, these type of molecules are called as enantiomers. You can see in the third and fourth. Here you can use a mirror. These two are mirror images because OH is here, Cl here. So these two are mirror images. But when you place this on this, when you take this and place this on this, H comes on Cl, Cl comes on H, OH comes on hydrogen, this H comes on OH. So that these are also non-superimposable mirror images. Hence 3 and 4 are also enantiomers. Okay, these type of compounds which are non-superimposable mirror images are called as enantiomers. Then what about diastereomers? These two are not diastereomers because these are mirror images. But look at 1 and 3. 1 and 3 are non-mirror image. This is not the mirror image of this. Hence 1 and 3 are diastereomers. Let's check for 1 and 4. 1 and 4 are also non-mirror images. 2 and 3 also non-mirror images, and 2 and 4 are also non-mirror images. Hence these set of molecules are called as diastereomers. 1 and 2, 3 and 4 are enantiomers. Because this and these two are non-superimposable mirror images. 1 3, 1 4, 2 3, 2 4 are non-mirror images. Hence these are diastereomers. This is about enantiomers and diastereomers. And enantiomers are having same physical and chemical properties, but direction to rotate the plane polarized light is different there in the enantiomers. In the diastereomers, physical and chemical properties are different. Let's look into another type of molecule which is not optically active because it is having plane of symmetry, but it is having two chiral carbons. Those compounds are called as meso compounds. See here, the meso compounds. This compound is achiral, means it is not optically active. It is a chiral compound having two or more chiral centers, and it is having plane of symmetry. Hence it is optically inactive. Even though it is optically inactive, it is having two or more chiral centers, and we need to study this. This type of compounds are called as meso compounds. Let's see the example. This is the molecule. You can see that this is a chiral center, this is a chiral center. So you can see there are two chiral carbons, but when you imagine the plane here, see this half is exactly same as this half, so that there's a plane of symmetry is there. Hence this type of molecules, this is non-active, it is not optically inactive. Hence this type of molecules are meso compounds. Here also you can imagine the plane, this half is exactly same as this part. Hence this one is also meso compound, 2 is also meso compound, because these are having plane of symmetry and these are optically inactive. Hence these type of compounds are called as meso compounds. Let's see into the third example. You can imagine the plane here, but this part is not exactly same to this part. Hence this is not meso compound. This is also different from this part, so that there is no plane of symmetry is present. Hence these two are not meso compounds. But these two, when you place the mirror here, this is the mirror image of this. These two are enantiomers. Okay, let's check the meso compounds, enantiomers and diastereomers. 1 and 2 are meso compounds because both are having plane of symmetry and achiral compounds having two chiral carbons, so that these are meso compounds. 3 and 4 are non-superimposable mirror images. Hence these are enantiomers. Let's check for 1 and 3. 1 and 3. These are non-mirror images, hence these are diastereomers. One and 3 are diastereomers. 2 and 3 are also diastereomers. 1 and 4, this and this also diastereomers, and 2 and 4 also diastereomers. Hence 1 and 2 are meso compounds, 2, 3 and 4 are enantiomers, and 1, 3, 1, 4, 2, 3, 2, 4 are diastereomers because these are non-mirror images. Like this, we have to distinguish these compounds. Let's take another example. This is structure of tartaric acid. The same groups are on the same side. Here also same groups on the same side, hence the prefix is erythro. Here same groups on the opposite side, hence it is Threo. These two are mirror images, correct? These two are mirror images. When you place a mirror here, these two are mirror images. But these are not optically active because these are meso compounds. Because when you imagine the plane here, this part is exactly same as this part. When you imagine the plane here, this part is exactly same as this part. Hence 1 and 2 are meso compounds. This is 1, this is 2. 1 and 2 are meso compounds. Let's look at the third compound. This is the mirror image of this. 4 is the mirror image of third one, but these are not meso compounds because there is no plane of symmetry. Hence 3 and 4 are enantiomers. Okay, then 1 and 3, just for 1 and 3, these are non-mirror images. 2 and 3 also non-mirror images. 1 and 4 and 2 and 4 also non-mirror images, hence these are diastereomers. 1, 3, 1, 4, 2, 3, 2, 4 are diastereomers because these are non-mirror images. Okay, hope we have understood what is meso compound, what is enantiomer, and what is diastereomers. Okay, thank you.